Welcome, I'm Mrs. C, and this is Math Defined. In today's video, I'll walk you through a complete guide to factoring algebraic expressions. We'll cover various methods to factor out the greatest common factor, or GCF, including the traditional method and the ladder method. Plus, I'll show you how to factor expressions with whole numbers, fractions, and negative coefficients. By the end of this video, you'll have a solid understanding of how to factor any type of expression. Let's get into it. Let's begin with a more traditional method for factoring out the GCF. This method has you find the GCF of the terms first and then use division to factor the expression. We'll begin by finding all the factors for the coefficient 21. We know 1 times 21 is 21, and 3 times 7 is 21. We'll do the same for the coefficient 49. 1 times 49 is 49, and 7 times 7 is 49. Now we need to look for the greatest common shared factor between them, and we see that it is 7. The next step is to divide each term in the expression by this GCF of 7. And 21m divided by 7 is 3m, and negative 49n divided by 7 is negative 7n. The last step is to rewrite the expression as the product of the GCF. To do this, we'll place parentheses around 3m minus 7n, because remember, parentheses mean multiplication, and then we place the GCF, which is 7, on the outside of them. And there you have it. 7 times the quantity, 3m minus 7n, is the factored expression of 21m minus 49n. Let's factor the same expression again using a different method called the ladder method. First, I'll place the expression into this ladder, which looks like an upside-down long division sign. Now I'm ready to start factoring. Looking at the coefficients, 21 and negative 49, I see that they share a common factor of 7. So I'll place this 7 on the outside of the ladder. Next, we divide each term by this shared factor of 7, just like we did using the traditional method. 21m divided by 7 is 3m, and negative 49 divided by 7 is negative 7m. Now looking at 3m minus 7n, we see that they do not share any other factors. So we are done factoring. We'll bring down 3m minus 7n, place parentheses around them, and place the GCF, which is 7, on the outside, and we're done. The ladder eliminates the first step of the traditional method of finding the GCF first before dividing. But let's look at some expressions where the GCF is not so obvious. This is where the ladder method is more efficient than the traditional method. Let's start with the expression on the left, 32y plus 48. First, we'll place it in the ladder. Then look for any common or shared factor. It doesn't have to be the greatest common factor, just any shared factor. I'll choose 4. Then I'll divide each term in the ladder by 4. 32y divided by 4 is 8y, and 48 divided by 4 is 12. Next, I see that these terms share an additional factor, so I'll need another ladder. And the shared factor I see is another 4. 8y divided by 4 is 2y, and 12 divided by 4 is 3. Now we are left with these two terms that do not share any common factors, so we are done with the ladder. We'll bring down the 2y plus 3 and place parentheses around them. The last step is to find the GCF for these terms by multiplying the two shared factors. And 4 times 4 is 16. So 16 is the GCF. We'll place it outside of the parentheses, and that's it. The factored expression is 16 times the quantity, 2y plus 3. Now let's simplify the expression 14x minus 28y. Since the two terms share a common factor, we need a ladder. Next, I'll choose a shared factor, and I know that 2 will divide evenly into both of these terms. Now I'll divide 14x by 2, resulting in 7x, and negative 28y divided by 2 is negative 14y. I see that these two terms share another factor, so we need to repeat the process again. This time, I see that they share a 7. And 7x divided by 7 is just x, and negative 14y divided by 7 is negative 2y. We're done factoring now because x and negative 2y do not share any common factors. So we'll bring it down and place the parentheses around them. Next, we need to find the GCF by multiplying the shared factors, and 2 times 7 is 14. The last step is to place this GCF of 14 outside the parentheses, and we're done. Now that we've covered factoring with whole numbers, let's take it up a notch and explore how to factor expressions involving fractions. Fractions might seem tricky at first, but the process is exactly the same. Let's look at this expression 1/3 b minus 1/3 to see how it works. For an expression with fractions like this, we factor out the coefficient positive 1/3. Remember, factoring out is the same as dividing out. So when you are asked to factor out the coefficient, in essence, you are being asked to divide it out of the expression. We need to factor out the coefficient positive 1/3 by dividing it out from both terms. So we'll divide 1/3 b by 1/3 and negative 1/3 by 1/3. We know that dividing 1/3 out of 1/3 b, the 1/3s will cancel each other out, leaving the variable b. And negative 1/3 divided by 1/3 will also cancel each other out, giving us negative 1. We will place these terms in parentheses, and the last step is to place the coefficient 1/3 outside of them. And now this expression has been rewritten in factored form. The coefficient 1/3 times the quantity b minus 1. Let's move on to the expression on the right. 1/2 x plus 3/2, or 3/2. We will factor out the coefficient. Since the coefficient is 1/2, we'll divide each term by 1/2. First, we see that these 1/2s cancel each other out, leaving the variable x. But it's not so easy for this second term, 3/2. We need to divide 3/2 by 1/2. Remember, to divide a fraction by another fraction, you multiply by the reciprocal of the divisor, which is the second fraction. So we'll multiply 3/2 times 2/1. Now we see that these 2's cancel each other out, and then multiplying the numerators, 3 times 1 is 3, and then the denominators, 1 times 1 is 1. And we'll simplify 3/1 to just positive 3. After dividing both of these terms by the coefficient 1/2, we are left with x plus 3. We'll place parentheses around them and then bring down the coefficient, and that's it. We're done. Now let's try an expression with integers and whole numbers, 4h minus 3. The coefficient that needs to be factored out is 4, so we'll divide each term by 4. The 4's cancel each other out, leaving the variable h, and negative 3 divided by 4 is just negative 3/4. So we're left with h minus 3/4. And we'll bring down the coefficient 4, and we're done. Moving on, we have the expression 5/2k minus 2. The coefficient is 5/2, so we need to divide each term by 5/2. The 5/2's cancel each other out, leaving the variable k. And we'll have to divide the second term, negative 2/1, by positive 5/2. We need to multiply by the reciprocal, and then multiplying the numerators, negative 2 times positive 2 is negative 4, and then the denominators, 1 times 5 is 5, giving us negative 4/5. So we are left with k minus 4/5. We'll bring down the coefficient 5/2, and we're done. Now that we've factored out with positive numbers and coefficients, let's look at what happens when we're working with negative numbers. Factoring out a negative value follows the same steps, but requires a bit of extra attention to the signs. Let's see how it's done with this expression, negative 4p plus 10. We're being asked to factor out a negative 2. And remember, factoring involves dividing, so we'll divide each term by negative 2. Starting with negative 4p, dividing it by negative 2 gives us positive 2p. And then dividing positive 10 by negative 2 gives us negative 5. We'll put these terms in parentheses with the factor we divided out, negative 2, on the outside, and we're done. Let's factor out let's factor out negative 6 out of 18z minus 15. Since factoring is dividing, we'll divide each term by negative 6. Positive 18z divided by negative 6 is negative 3z. And then we'll divide negative 15 by negative 6. So negative 15 divided by negative 6 is a fraction. And because both the numerator and the denominator are negative, this fraction becomes positive 15 over 6. Now we can reduce it by dividing both the numerator and the denominator by the shared factor of 3. And 15 divided by 3 is 5, and 6 divided by 3 is 2. So dividing negative 15 by negative 6 results in positive 5 over 2. Finally, we'll put these terms in parentheses with the factor we divided out, negative 6, on the outside. In this next expression, we're going to factor out a fraction, negative 1/4. Don't let fractions overwhelm you. The process is still the same. So the first step is to divide both terms by negative 1/4. Now we have a pair of complex fractions to solve. But don't worry, these are just division problems. We'll start with negative 1/2 divided by negative 1/4. In order to divide this pair of fractions, we need to multiply by the reciprocal. Next, I see that I can cancel the 2 and the 4 because they share a common factor of 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. Now we will multiply the numerators. Negative 1 times negative 2 is positive 2, and then the denominators, 1 times 1 is 1. And we'll simplify 2 over 1 to just 2. So negative 1/2 x divided by negative 1/4 is positive 2x. Now let's divide negative 5/4 by negative 1/4. Again, we need to multiply by the reciprocal. Next, we see the 4's cancel each other out. Multiplying the numerators, negative 5 times negative 1 is positive 5, and then the denominators, 1 times 1 is 1, giving us 5 over 1, which simplifies to just 5. So negative 5/4 y divided by negative 1/4 gives us positive 5y. Don't forget to bring down the variables with the terms here. It is so easy to forget them. We'll put these terms in parentheses with the factor we divided out, negative 1/4, on the outside. And we're done. Thanks for watching, and I hope you found this step-by-step guide helpful. And until next time, keep math awesome.